Okay, so I talked about this a little bit in another video, that there are different types of equations. So one is called a conditional equation. So let's say we had an equation earlier, it said x plus 7 equals 10, right? And we said, oh, x is 3. That is an example of a conditional equation. This is true on a condition of x. Like it's only true if x equals 3. If x is any other number, it's not true. Okay? So right now, that equation isn't true or false. It depends, right? It depends on the value of x. If x is 3, then it's a true equation. If x is something else, like 2.2, then it's not a true equation. So that's why it's called conditional. It's dependent on the value of x. Okay? We also have what's called another type of equation that's called an identity. So let's say you have 2x plus 7 equals 2x plus 7. Well, you know what? That's always going to be true. It is not dependent on the value of x. I've got the same thing on the left that I do on the right. It's always going to be true. This is always true. And it doesn't depend on the value of x. In that case, when we're solving an identity, the solution set is all real numbers. Now, sometimes they write out all real numbers, and sometimes they'll just put the interval notation, negative infinity to infinity, which is fine. That's all real numbers, okay? Now, I have students that don't always, recognize the identity, and so they're like, okay, let me solve this equation, which is great, So they're like, let me get x on one side. And then they're like, okay, those cancel out, I get 7. Those cancel out, I get 7. And then they're like, uh-oh, I lost my x. Well, that's not a problem. It just means 7 equals 7. That is true. And it's always going to be true for any value of x. It just means that we're not dependent on the value of x for this equation. It's always going to be true. Sometimes students try to squeeze a little x in, like they'll put like a little x in there because they don't want to lose their x. Don't do that. then it becomes a conditional equation, and then that's not what we had. Okay? So this is okay. It just means that it's all real numbers. It's always true. It's an identity. Sometimes I have students that even want to, let me subtract 7 from both sides. See if that helps. Yeah, 0 equals 0. That's a true equation. Still all real numbers, not dependent on the value of x. Okay, then our third type of equation is inconsistent. Sometimes they'll call these a contradiction. Some textbooks use the word contradiction. Okay, so let's say we have 3x plus 5 equals 3x minus 6. Well, we're solving our equations. We're getting x on one side. And look at what happens. The x's cancel here, and the x's cancel here. And we get this statement, 5 equals negative 6. Well, that is not true. In fact, it's never going to be true. Not true. So again, don't let it throw you. If you lose your x, it just means it's either an identity or an inconsistent equation. If it's an identity, then all real numbers, that's the solution. If it's a contradiction or inconsistent, then it means it's never going to be true. No matter what the value of x is, it's not going to be true, and that means there's no solution. So think about what we had up here originally. 3x plus 5. So you take a number and you multiply it by 3 and you add 5 to it. Is it ever going to equal if you take a number, multiply it by 3 and subtract 6 from it? No. So that's why it's a contradiction or it's inconsistent. It's never going to be true. You can put in x values all day and it's not going to work out. So that's why there is no solution. Now, these come up when you're solving. So usually there's no big banner that says, hey, watch out, for this. And it's just going to happen when you're solving and you have to know what to do with it. It doesn't mean it's a bad thing. And I think that's all I wanted to say on that. Okay. So it says solve and determine the type of equation. Okay, looks like a regular equation. By the way, that's what I was going to say. You can't always tell just by looking at them if it's conditional or an identity or whatever. All right. I would distribute 2x plus 2, 2x plus 3. Now at this point I might say, something looks fishy here. But let's say I didn't. I'm just happy solving my equation with my steps that I've learned. And then I get 2 equals 3. Now something should look fishy to you. Okay, you've lost your x. 2 does not equal 3. So this is inconsistent. And then I kind of have to make a big deal out of this. It says solve and determine the type of equation. It's inconsistent. The solution, though, is the empty set. Okay, so in this particular problem, because they asked for both, they asked us to solve and determine the type of equation, I have to put both things in. Okay. Usually I just say solve. All right, solve and determine the type of equation. All right, well, here we go. 4x plus 6. We're going to distribute here. 6x plus 6 minus 2x. So now we're going to simplify each side. 6x minus 2x is 4x plus 6. You might see it there. I see it. But if you don't, you might subtract 4x from both sides. You don't have to. You could just see it. 6 equals 6. Okay, and at that point you probably see it for sure. But this is going to be all real numbers. And like I said, sometimes they have you just type out all real numbers. Sometimes they want the interval notation, which is -∞ to infinity. And then this was an identity.